Okay, thank you, Jennifer. So I'm quite glad, actually, that I think it was Jeff at the beginning of his talk mentioned that we don't do a very good job of measuring how polluting we are in the real world. And obviously, the way we drive and the way we use vehicles has a direct impact on that. So the first slide I put in was all about that, to kind of set the scene for some of the driver observation and modelling and interaction work that we're doing at Bath. Sometimes the world of driving presents us things like that. Sometimes it presents us things like that. Ironically, both of those photos were taken by me on bicycle rides. The thing about that is the world that we see as drivers changes every day, and the way we react to it changes every day. And the way we test for it always stays the same. And if these little boxes here are the operating window that we've got to play with in a car, the test cycles, and that will be doubtless familiar to many of you, they only cover a little tiny bit. And even, the new one, which is better, still only covers a tiny bit. At Bath, we've done some work with gathering data in the real world. We can do portable emissions testing and things like that. We've got a whole load of driving here, and all those drives added together covered that much of the available operating window in the vehicle. So that is the difference between what we do in emissions testing and the numbers that the company, the OEMs, quote to us, and what we actually see happening in the real world. So why the differences? Well, I've already sort of said, and it's the title of the talk as well, that the driver is quite key here. We can't reasonably put together something that tests all of every possible available scenario or reaction to things that people see in the real world. We can do a reasonable job. We've got a reasonable understanding of how things like, the geography, even things as changeable as weather and traffic conditions, impact on the way people behave in cars. And we understand how a lot of those things, where they are interacting directly with the vehicle itself, interact with the vehicle. But, unfortunately for us, the vehicle has got a big squishy thing in the middle of it that does looking at things and thinking and making decisions all the time. And those decisions for the same person on a different day in a different situation will change. We're trying to get a handle on that through some of our work. So the project that we've got going on at the moment that I'm involved with is within the Powertrain Centre, but it also crosses over to a psychology and human factors project. The aim of it is to try and understand how we go from real-world things that we can observe with perhaps sensors and things like that to what the vehicle is going to experience. And obviously, there's that gap in the middle that's filled by the driver. So the crucial thing is trying to get some sort of a handle on, even if it's only very short term, how a driver is likely to react to things. We're working with an industrial partner who have got a driver assist device, which, again, I'm glad people have been talking about fleet operators, because this Lightfoot device has been rolled out in a number of vehicle fleets, delivery vans, that kind of thing in the southwest. And actually, what it does is it gives you visual, and then if you're what it thinks very badly behaved, audible warnings that you're driving in a non-environmentally friendly way, and we'll talk a bit more about what that means in a moment as well. And one thing that we do know is that within the context of those fleets, that's given a quantifiable reduction in fuel consumption, and a nice byproduct of that is it's also reduced the number of accidents they've been having, because essentially what it tells you to do is back off a bit. These kind of systems, and there's other things out there, and I'm sure OEMs are working on similar things, even crude measures like putting shift lights in vehicles and that kind of thing, which is starting to appear. They tend to use relatively basic measures at the moment. And the one that we looked at quite a few years ago that then went into the company that developed that was something called inertial power surrogate, which essentially is a measure of how heavy-footed you're being. Now, if we take a whole load of data, this is from a load of drives of the same commute by the same person on different days, and there's a lot of hours of data in there. And it looks like a big blob if you just plot it, but there are trends, and if you plot it against inertial power surrogate, which I failed to label on the bottom there, you see actually if you reduce the value of that, ultimately you're looking at a less polluting place for fuel consumption and NOx, fuel consumption obviously being analogous to carbon emissions as well. So in theory, if you just tell the driver, okay, you're being aggressive, back off a bit, which is what that does and is in use now doing, then, you know, potentially you're in a good place. One thing that we've begun to observe is that isn't necessarily the case in the real world. And this is stuff that, a lot of the stuff we've talked about today is quite long-reaching, quite global in its outlook. Actually, this stuff about how we use vehicles that we've got right now, regardless of what changes come out into the vehicle arena, is relevant to all of us right now. So we've got a situation here where, hopefully this is familiar to a lot of people. You've got a cross junction or T-junction, you're pulling out, turning right across traffic or maybe into oncoming traffic. Different things, different days. We've got a load of people driving that. The same person driving that a load of times, and you can see, you know, what you would traditionally call more aggressive and less aggressive behaviour pulling out of that junction. Here he's accelerating very fast. Here he's not, and the others are somewhere in the middle. And for that, again, fuel consumption matches pretty well to what you'd expect, and the metric that I mentioned also matches pretty well to what you'd expect. Here you've got some quite big peaks in it. And that's all well and good. However, we now look at the other thing which is starting to finally gain a bit more presence in the way legislation is structured, which is oxides of nitrogen. And we see that both of those drives, the very classically aggressive one and the very gentle one, both come out quite near the bottom in terms of tailpipe NOx, which is this bottom one here. And the others are somewhere in the middle, even though we wouldn't perhaps expect them to be. And it's worth pointing out at this point, and this is where I was glad of Jeff's comment earlier, that this is about 3 kilometres, and we're looking at between 1 and 3 grams of tailpipe NOx. And this is off a mainstream, relatively large diesel family car, okay? The Euro 5, Euro 6, it's a Euro 6 compliant vehicle, at least in theory. Permitted regulations are an awful lot less than that. So that's the difference between what we see in a lab environment with very limited driving cycles and what we potentially see in the real world. And most of that, you see, is coming out, you know, right at the beginning where you pull out and put your foot down. So again, another technical, relatively technical side, and I apologize for that, but it is also pictures, which is good. So the reason why we see some of these disparities, we're always told, you know, back off, change gears sooner, low engine speeds, high torques, and all the rest of it. And that's because that puts us, if this is engine speed and that's the amount of load it's under, that's a nice high efficiency place to be in terms of thermal efficiency. So we get a lot of go out of the fuel we put in. However, by doing that, we put cylinder temperatures up and pressures, which promotes the production of NOx. And this is actually from that data from the various drives, and we've got a lot of driving around that we're looking at. That there is high NOx output, which is kind of connected with the same region, which I suspect is why some of these ones in the middle here, which are still quite aggressive but less fuel hungry, are quite polluting in terms of some of those other less pleasant chemicals that we really don't want to be chucking lots of into the atmosphere, either on a local or global scale. So one of the other points I'd like to make about how we deal with driver behaviour and what they do is, at the moment, I'm talking about internal combustion. We've talked a lot today about getting rid of internal combustion or moving away from it and hybridization and things like that. Actually, all of this stuff is more easy to apply to improving range on electric vehicles, which is something that probably does need discussing at some point. I'm not sure if we actually have done yet. We've talked a lot about batteries, but the underlying fact there is that to make electric vehicles acceptable to the user, they need better range than they currently offer. So this idea of how do we get the most out of a vehicle by helping the driver, by understanding what it is they want to do next and optimising for that, that is definitely relevant there. It's even more relevant in the intermediate stage of hybrids, because hybrid vehicles already present quite a complex optimization problem because we've got multiple different energy sources and we need to know when best to use them. And again, the human factors, if you like, the softer side of what we're doing, is very much relevant to the increasing autonomy that we're talking about in vehicles as well. So that, actually, if we put a human in a position where they're given a system to interact with they're not too sure about, then that's not a good thing from the point of view of usability, and they won't accept that change. So that piece of understanding is relevant there too. I'm conscious that I'm probably out of time now, but essentially, what I want to conclude with is that we're working on things that are currently open questions and it's ongoing research, and the end game is to try and help people use the vehicles they've got as effectively as possible and inform design decisions for control systems on vehicles down the line. Thank you.